F-16 Ace. Imagine taking a legendary fighter jet whose original electronic brain dates all the way back to the 1970s, completely gutting it and transforming it into a 21st century technological marvel. In May 2001, at the highly secure Flight Test Center located at Israel's Ben Gurion International Airport, that exact vision took flight. Spearheaded by Israel Aircraft Industries' Lahav Division and Elbit Systems, the F-16 Ace, short for Avionics Capabilities Enhancement, successfully completed its maiden flight. It was such a triumphant success that immediately following its test flights, the jet was flown directly to France to be the star of the 2001 Paris Air Show. The sheer scale of collaboration required to build the Ace was staggering. It wasn't just IAI and Elbit. An entire army of elite defense contractors, including Elta Electronics, Rafael, Israel Military Industries, El Op, and Astronautics joined forces alongside Lockheed Martin and the Israeli Ministries of Defense and Finance. Together, they created a breathtaking full-glass cockpit. The old analog dials were stripped away, replaced by three brilliant 5x7-inch color screens. A new wide-angle head-up display, HUD, developed by ELOP, projected crucial data onto the canopy, while an advanced helmet-mounted display, HMD, engineered by Elbit, allowed the pilot to lock onto enemies simply by looking at them. At the core of this beast was the highly capable Israeli EL-M2032 radar. Utilizing cutting-edge synthetic aperture radar (SAR) technology, it delivered outstanding performance in processing both air and ground targets simultaneously. But the true genius of the F-16 Ace was its open architecture design. It featured true plug-and-play capability. This meant that integrating future sensors, external data links, or new weapon systems wouldn't require heavy, expensive hardware modifications. A simple software update was all it took. To reduce the immense workload of modern combat, designers added a new upfront control panel directly in the pilot's line of sight, a design deeply rooted in the extensive real-world combat experience of Israeli pilots. Because these pilots are famous for their incredibly aggressive, high-G flying styles, the jet's physical airframe underwent the Falcon Up structural enhancement program. Armed with Rafael's Lightning targeting pods, colossal 600-gallon drop tanks, laser-guided bombs, Popeye air-to-surface missiles, and the deadly Python 4, the F-16 Ace proved that an old airframe could be reborn into an apex predator.
Kfir C-7. To truly understand the rugged brilliance of the Kfir C-7, we have to travel back to 1983. Israel had already successfully built the baseline Kfir fighter, but they knew it needed a massive leap in capability to survive the modern battlefield. The resulting C-7 modernization program turned an already capable jet into a remarkably lethal strike platform. The transformation started inside the cockpit. The avionics suite underwent a massive overhaul, introducing modern HOTAS, hands-on-throttle and stick flight controls. This allowed pilots to command weapons and radar without ever letting go of the controls during intense dogfights. The aircraft was equipped with the WDNS-391 navigation system, a marvel of its time that boasted an incredibly low navigation drift of less than 800 meters per flight hour. It also gained a brand new video system, enabling the use of highly accurate precision-guided munitions. But the most striking visual difference of the Kfir C-7 was its sheer payload capacity. Engineers managed to add two brand-new hardpoints directly under the engine air intakes, bringing the total number of weapon pylons to 9. This allowed the Kfir C-7 to carry a staggering maximum payload of 6,085 kilograms. Built-in armament consisted of twin 30mm DEFA 5.52 cannons with 140 rounds per gun. For air-to-air combat, it could carry Sidewinder, Python 3, or Shafir 2 missiles. For devastating ground attack missions, those underbelly pylons could hold massive 1,360-kilogram Mk-118 bombs, Shrike or Maverick missiles, GBU-15 glide bombs, and even cluster munitions and napalm. To handle all this extra weight, the engine was heavily modified. Engineers introduced a special combat mode, allowing the pilot to temporarily boost the engine's thrust up to 83.41 kilonewtons. Survivability was also boosted, with late production models receiving ELISRA hemispherical radar warning sensors under the nose and on the tail fin, complemented by an ELTA electronic countermeasures pod. Long after its production ceased, the Kfir C-7 found great success on the export market. As late as 2011, these rugged fighters were still dominating the skies in active service with the air forces of Colombia, Ecuador, and Sri Lanka, supported by advanced digital flight simulators equipped with projection-based visual systems.
Kfir C-10. If the C-7 was a heavy hitter, the Kfir C-10 was the ultimate uncompromising evolution of the platform. Its story is one of sheer engineering resilience. It was born directly from the ashes of Israel's highly ambitious but ultimately canceled Lavi fighter program. When the Lavi project was shut down, Israeli engineers refused to let their groundbreaking research go to waste. Instead, they initiated a new project dubbed the Namr, or Tiger, designed to absorb and integrate the cutting-edge avionics developed for the Lavi into the Kfir airframe. The C-10 was envisioned as a true dual-role platform, excelling in both air superiority and precision ground strike missions. While it retained the iconic fixed canards of its predecessors, its physical design was altered dramatically. It featured an extended nose section to house new electronics, and its dorsal fin was completely removed. Inside the modernized cockpit, the pilot was greeted by two multifunction displays pulled straight from the canceled Lavi program. But the absolute crown jewel of the C-10 was the multi-mode IAI ELTA EL-M2032 radar. This advanced pulse Doppler system gave the jet phenomenal capabilities. It utilized low and medium pulse repetition frequencies to provide flawless look-up and look-down tracking. It could reliably detect low-flying enemy aircraft hiding amidst heavy radar ground clutter and project all vital aerial target data directly onto the pilot's head-up display, a design philosophy intriguingly reminiscent of the Russian MiG-23. Furthermore, the completely overhauled avionics architecture fully integrated the lethal Python 4 air-to-air missile. Historically, selling the Kfir to other countries had been a bureaucratic nightmare because its American-made J-79 turbojet engine required strict U.S. export approval. To cleverly bypass this restriction, beginning in 1987, Israel explored ripping out the American engine and replacing it with European power plants. They evaluated the French Snecma ATAR K50, yielding 7,200 kilograms of thrust, and the Swedish Volvo RM12, offering 8,230 kilograms of thrust. Taking its maiden flight in 1991, the extensively modernized Kfir branched into several highly successful export programs, resulting in variants like the Kfir CE for Ecuador and the Kfir COA for Colombia.
F-15I RAM. In the mid-1990s, Israel faced a shifting geopolitical landscape. Neighboring nations were aggressively modernizing their air forces with advanced combat aircraft, creating a perceived erosion of Israel's long-standing qualitative edge. To counter this threat, In May 1994, the Israeli Ministry of Defense signed a massive contract with Boeing for 25 F-15I tactical fighters. Based on the legendary U.S. Air Force F-15E Strike Eagle, this was a highly customized variant tailored specifically for deep strike air-to-ground missions. Within the ranks of the Israeli Air Force, these formidable machines were aptly christened the Ram, which translates from Hebrew to thunder. The first F-15Is touched down in Israel in January 1998, and they immediately got to work. By November of that year, 10 of these advanced fighters were stationed at Tel Nof Air Base, rapidly racking up over 1,200 training sorties. They even crossed the globe to Nellis Air Force Base in Nevada, where 3 ROMs and 35 Israeli personnel participated in the prestigious, highly intense U.S.-led Red Flag combat exercise. Once deliveries were complete, the 25 jets formed the absolute backbone of the elite 69th Squadron. What made the F-15I so uniquely terrifying compared to the standard American Strike Eagle was the integration of a highly classified indigenous electronic warfare suite known as the SPS-2100. This formidable Israeli-built system incorporated an active radar jammer, a radar warning receiver, and a missile approach warning system, making the ROM incredibly difficult to target or shoot down. Military analysts stressed that the F-15I possessed completely unmatched combat capabilities in the region. For instance, even the Royal Saudi Air Force's F-15S, another Strike Eagle derivative, featured heavily downgraded tactical specifications. The Saudi jets used a downgraded export version of the APG-70 radar, hobbled by a less powerful processor and reduced computer memory. Israel, however, retained the full, terrifying power of the multi-mode APG-70 radar. Furthermore, integrating the jet was incredibly cost-effective for Israel. Major domestic defense contractors were deeply involved in manufacturing the components for the Boeing-built jets, drastically streamlining the supply chain and ensuring the ROM could project Israeli air dominance across unprecedented distances. MiG-21 2000. In the early 1990s, the aviation world witnessed a partnership that left Russian engineers absolutely furious. Russia was actively trying to sell modernization packages for its aging MiG-21 fleets around the world. So it came as a massive, unwelcome shock to Moscow when in early 1993, the Romanian Air Force bypassed Russia entirely and signed a massive upgrade contract with Israel. Israel Aerospace Industries, Elbit, and the Romanian firm Aerostar teamed up to modernize roughly 100 Romanian MiGs. The prototype for what would become known as the MiG-21 2000 was actually based on a MiG-21 BIS airframe that Israel had discreetly and rather mysteriously acquired from Nigeria. The engineering philosophy was absolutely brilliant. Menachem Shmuel, IAI's chief test pilot, explained that while the 1950s airframe was incredibly fast and structurally reliable, its weapons and avionics were woefully obsolete. The primitive original radar had a dismal, almost useless range of just 12 nautical miles. So the engineers completely gutted the old Soviet wiring. Integrating the elite Israeli EL-M 2032 multi-mode radar required a total replacement of the aircraft's electrical system. Suddenly, this old Soviet workhorse had a modern glass cockpit with 3 multifunction displays, HOTAS controls, and an upfront control panel. Israeli designers even added an IAI-developed helmet-mounted sight, allowing the pilot to perform off-boresight targeting. Amazingly, the new Israeli Core Fire Control computer was so advanced that it alone processed the workload that required 8 separate computers on previous aircraft. But the most ingenious trick was the fuel.
Because modern microchips and avionics are a fraction of the size of 1950s Soviet vacuum tubes, the engineers suddenly found empty physical space inside the jet's fuselage. They used this space to add an extra 200 liters of internal fuel. Combined with a 1,200-liter drop tank, the MiG-21-2000's combat radius was increased by a massive 50%. The canopy was replaced with a seamless, one-piece design that was 50% stronger to resist bird strikes and offered vastly superior visibility. When the jet made its public debut at the 1993 Paris Air Show, emblazoned with Israeli and Romanian flags, the Russian Mikoyan Design Bureau was outraged at being entirely excluded from the lucrative 5,000-jet global market. Armed with Griffin laser-guided bombs, highly agile Python 3 infrared missiles, and Rafael electro-optical targeting pods, the MiG-21-2000 became a deadly, budget-friendly fusion of Eastern aerodynamics and Western digital supremacy.
LAVI. By the early 1980s, Israel's aviation industry had matured to a point of extreme confidence, largely driven by the success of the Kefir. This newfound expertise emboldened the nation to embark on an almost impossibly ambitious project, the creation of a highly advanced, indigenous combat aircraft built from absolute scratch. Christened the LAVI, meaning lion, this platform was conceived as a close air support and battlefield interdiction fighter designed to finally break Israel's reliance on foreign arms suppliers. The baseline LAVI was an absolute marvel of aerospace engineering. It featured a tailless Delta Canard configuration with a low-mounted swept wing featuring a 54-degree leading-edge sweep. The airframe was incredibly futuristic, making extensive use of advanced composite materials. Carbon fiber composites accounted for a massive 22% of the aircraft's total structural weight. Aerodynamic control was managed through 9 rapidly movable surfaces, all governed by a quadruplex redundant digital fly-by-wire system with absolutely zero mechanical backup. Inside the cockpit, designers made a fascinating, highly specific choice. While the American F-16 featured an extreme reclined seat, Israeli pilots frequently reported that this caused excessive painful strain on their neck and shoulder muscles during high-G dogfights. Therefore, the LAVI's Martin Baker Mk-10 ejection seat was installed with a very modest 10-degree recline angle, prioritizing pilot combat endurance. The jet's digital brain was astonishing. 60 to 70% of the avionics were domestically produced. The heart of the sensor package was the ELTA EL-M2032 radar, boasting a maximum detection range of 56 kilometers, featuring high-resolution ground mapping and terrain avoidance using Doppler beam sharpening. The entire system was powered by a distributed computing architecture comprising 17 processors. The core Elbit ACE-4 mission computer weighed just 54 kilograms, but offered a blistering processing speed of 600,000 operations per second, with an impressive mean time between failures of 2,500 hours. The pilot absorbed all this data through a cutting-edge glass cockpit featuring 3 multifunction displays, a wide-angle Hughes HUD, and a revolutionary fiber-optic helmet-mounted display, offering a massive 30 by 30 degree field of view. The first prototype soared into the sky on December 31, 1986. The master plan called for 300 production aircraft. But this technological masterpiece was headed for a tragic political end. The United States had heavily subsidized the development phase, but was completely unwilling to underwrite the massive financial burden of full-scale serial production, essentially refusing to fund a direct competitor to their own F-16. Without this critical American backing, the required capital was insurmountable.
In August 1987, after just 82 test flights, the Israeli government made the agonizing decision to cancel the Lavi. Yet its spirit lived on. A third two-seat prototype was completed in 1989, serving for decades as a flying technology demonstrator, ensuring the Lion's roar would echo in every Israeli jet built thereafter.